Yeah, so hello everybody, this is Suyash Goyal signing in. I hope you all are doing very well. So we are again here on YouTube in this particular session to talk about one more interesting topic, and this time we are here to discuss something about class 11th, and the topic that we're going to talk about is complex numbers. So again, this is a very important topic as far as your class 11th mathematics is concerned. We're going to talk about it, we're going to discuss everything about it, and I mean, we have the next 1 hour available with us, and let's see how much can we know. There is something new about this topic. So we'll begin in the next 1 to 2 minutes. I'm just waiting for some students to join us, and once we have some students with us, we can surely proceed with the session, guys. Okay. So meanwhile, let me tell you about myself. This is Suyash Goyal signing in. I have been associated with Unacademy since November 2017, and I have more than 5 lakh views and more than 70,000 followers on Unacademy. Okay, and here we are connected to talk about, as I told you, one interesting topic of 11 mathematics, that is complex numbers. So let's wait for just 1 more minute and let's see if we have some more students joining us in the live session so that we can begin with the session. Okay. Hey guys, how are you? I see some students joining this session. Guys, can we have a conversation over here? Can you write something in the comment section so that I can just get to know that yes, you guys are there? Okay, then let's move forward. We have the students with us, and I think there is a time to begin with the session. So, guys, first of all, I would like to know that all of you are well or not. Hello, Amir, how are you? Kya bolti public? I don't know, man. We are discussing here complex numbers. So let's begin with this. And here we are going to start with this. And I hope you all are fine with your families in these strange times. And on this note, let's talk about complex numbers. So, guys, we all are coming from 10th. So I'm talking about the students who are in 11th. We all are coming from 10th. We all are coming from a background when we talked about real numbers, when we talked about real rational numbers, when we talked about irrational numbers, when we talked about integers, natural numbers, whole numbers. And if you remember, when we talked about all these numbers, we started with what? We started with the natural numbers. So we have the natural numbers, and then when we add 0 to our natural numbers, it becomes whole numbers. Okay, we have natural numbers, and when we add 0 to the set of natural numbers, it becomes whole numbers. Okay, then again, when we have whole numbers, so when we add the negatives of natural numbers to the whole numbers, okay, the negative of natural numbers to the whole numbers, we have something which we call what? We have some things which we call integers. Okay, and then we got a term that is rational number. How? So basically, when we talked about integers, we have the form like -3, -2, 1, 2, 3, 4, 5, 6, 10, 20. These are integers, including 0. What about the fraction form? What about if I have 3 by 5 or -3 by 5 or 6 by 5 or -6 by 5 or -5 by 6? So for all these cases, we actually categorize thing on a broader way, and we got rational number. Okay, so we have natural numbers, all natural numbers plus 0 makes whole numbers, all whole numbers plus negatives of natural numbers makes integers, and all integers plus all numbers which are of the form p upon q, where p and q are integers and q is not equal to 0, it makes rational numbers. Okay, are you getting it, Amir? And when we collected all these rational numbers and all these irrational numbers, then we form something which we call real numbers, the father and mother of all the numbers. Okay, so when I'm saying real numbers includes all the numbers that we can think of, that we can talk about till now. कॉम्प्लेक्स नंबर पढ़ने से पहले तक जितने भी नंबर हम लोग को पता थे, जितने भी नंबर के बारे में हम लोग बात कर सकते थे, whatever we knew about numbers, or everything was real number. Okay, so we talked about numbers and everything is included in real numbers, and now we have something else, and now we have a new term which we call complex numbers. Now the point is that why do we need it? Why do we need it? So basically, guys, what happened is, when I'm talking about a particular equation that x minus 2 is 0. Okay, when I'm saying x minus 2 is 0, so it becomes pretty clear to me that when x minus 2 is 0, it means x is going to minus 2. Okay, x will be equal to plus 2, right? So plus 2 is my integer. Okay, plus 2 is my natural number. When then we have an equation like x plus 2 equal to 0, and that is why we had to introduce integers, because x plus 2 equal to 0 को जब solve करूँगा, I will get x equal to minus 2, and minus 2 is not an integer. Minus 2 is not a natural number, rather than it is an integer. So it is dependent on the equation that we are solving. Okay, then similarly we talked about 2x minus 3 equal to 0. So when I solve 2x minus 3 equal to 0, I get x equal to 3 by 2. Now 3 by 2 is neither my natural number, nor my whole number, nor my integer. That is why we introduce a new form, that is rational number, because this 3 by 2 is a rational number. Similarly, if I talk about equations like x square plus 1 equal to 0, that you can see over here, can you solve it using your real numbers? I mean, when you are going to talk about this equation x square plus 1 equal to 0, what are you going to do? You have x square plus 1 equals to 0, which means x square is going to be equal to what? X square is going to be equal to minus 1, and this makes it that x will be equal to root of minus 1. Make sense or not? X will be equal to root of minus 1. Now when I'm saying x is equal to root of minus 1, can you solve it? Can you find any rational number or any irrational number or any natural number, whole number, or any integer for this particular x? You actually can't. Getting it? That's the whole point. So when Euler, so there's a scientist whose name was Euler, you must have heard about it. He was a mathematician. Euler was there, and when he got through such equations, he got trouble that he was not able to solve them, and that is why he introduced something which we call complex numbers. Okay, so he introduced this term, that is root of minus I by the symbol iota. This I, ये जो I यहाँ पर हमने लिखा है, this I is known as what? This I is known as iota. Getting it? So basically when he talked about root of minus 1, so this root of minus 1 is known as iota, and we represent it by the symbol I, and this is the first step towards our complex numbers. Okay, so the numbers that are not included in real numbers, the numbers that we cannot think of, are the numbers which form with this iota. ओके अभी थोड़ा और देखेंगे कॉम्प्लेक्स नंबर्स के बारे में, ब्रॉड वे में ये क्या होते हैं, व्हाट डज कॉम्प्लेक्स नंबर इंक्लूड एंड ऑल दैट, बट राइट नाउ लेट्स टॉक अबाउट दिस आई. थोड़ा सा इस आई के बारे में बात करते हैं. सो द प्रॉब्लम दैट वी हैव इज एक्स स्क्वायर इज इक्वल टू रूट ऑफ माइनस 1, and till now before complex number we have never solved root of any negative number. I mean, if I have root 3, root 5, root 7, root 10, root 11, root 20, that's fine with me. But if I have root minus 3, root minus 5, root minus 7, root minus 4, root minus 10, root minus 20, this is a point of concern for me. Getting it? Why? Because I do not know how to handle the root with a negative number. Okay, so here we have something for that particular scenario. We replace root of minus 1 by what? We replace root of minus 1 by the symbol iota. Okay, and now when we have root minus 1 equal to iota, or let's say it in this way, when we have iota equals to root of minus 1, when we have iota equals to root of minus 1. So now let's square both the sides. Okay, so when we are going to square it both the sides, I have iota square equals to root of minus 1 ka square, which will be iota square is equal to minus 1. Make sense to you or not? Amir, are you there? Everyone, all of you who are there, guys, make sense to you or not? So we have root of minus 1 as iota. Okay, we have root of minus 1 as iota, and hence we can say that iota square will be what? Iota square will be minus 1. Getting it, guys? Till here, clear? Guys, is that clear? Please tell me. I need you to be conversational. I need you to speak so that we can have a discussion on such topics, right? So please speak. If you didn't understand anything, please let me know so that we can just clarify it right here, right now. Okay, so let's move forward. The next, what we are going to talk about is this iota. We are going to continue with that. So when we have iota equals to root of minus 1, as I told you, when we have iota equals to root of minus 1, it means that iota square will be minus 1. Why? Because I'm going to square it both the sides. I have iota is equal to root of minus 1. Squaring both the sides, I have iota square equals to minus 1. Okay, I have iota square equals to minus 1. Now this means what? This means that iota is a solution of the equation x square plus 1 equals to 0. Are you getting this or not? Okay, so this means what? This means that iota is a solution of the equation x square plus 1 equals to 0. Now why am I saying this? Because when I'm going to find out this x square plus 1 equal to 0, and when I'm going to solve it, so I will be having x square is equal to minus 1 ka root, or let's say x square equal to minus 1 right now. Okay, so I have x square equal to minus 1. What do I have? I have x square equal to minus 1. When I have x square equal to minus 1, I can put it in this way, that x is equal to root of minus 1. Make sense or not, guys? X is what? X is equal to root of minus 1. Clear? Guys, getting it or not? X is equal to what? X is equal to root of minus 1. Okay, and root of minus 1 is nothing but this iota. So we have x is equal to what? We have x is equal to iota. That is the solution of this particular equation. Okay, now when we continue talking about complex numbers, what is complex number? Why do we have complex number? How do we denote complex number? So any number that is of the form a plus iota b, any number that is of the form a plus iota b, जहाँ पे a और b क्या है मेरे, जहाँ पर a और b मेरे real numbers हैं, we define this as what? We define this as a complex number. तो कोई भी number जो हमारा a plus iota b form का है, कोई भी number जो हमारा क्या है, कोई भी number जो हमारा a plus iota b form का है, जहाँ पे a और b real numbers हैं, that is defined as a complex number. Okay, like for example, if we talk about an example, so we have 2 plus 3 iota. We have what? We have 2 plus 3 iota. Then we have minus 1 plus root 3 iota. Then we have, or let's say 2 plus iota 3, or minus 1 plus iota root 3. Then we have 4 plus iota minus 1 upon 11. All these are complex numbers. Okay, now there is one thing that I want to tell you. As I told you from the very beginning, that when we have the natural numbers, we add 0 to those natural numbers, and the whole set becomes whole numbers. Then I added what? Then I added negatives of natural numbers to the whole numbers, and we have the integers. Okay, then we added p upon q form. Okay, so it becomes rational numbers. Then we combined rational and irrational, so these became real numbers. And when we combine the real numbers and the imaginary numbers, we have something what we call complex numbers. Okay, so when I'm saying that what are complex numbers, so complex numbers is any real number. I mean all the real numbers are complex numbers. I tell you how. Because when we have 2, let's say I'm talking about 2, or let's say I'm talking about -1, so I can simply I write it as 2 plus 0 iota, or -1 plus 0 iota. Okay, so here you can see that when I have the coefficient of iota to be 0, again the number is what? Number becomes real. Okay, getting it? So basically each and every real number is a complex number. Okay, each and every real number can be represented or can be written in the form of a complex number, so that if I have -5 by 11, so I can write it as -5 by 11 plus 0 iota. Okay, similarly if I have 6 by 5, so I can write 6 by 5 as 6 by 5 plus 0 iota. Okay, similarly if I have -3, so it could be written as -3 plus 0 iota. So all the real numbers are what? All the real numbers are nothing but are complex numbers. Okay, so taking this discussion forward, we have something about complex number. If we discuss this complex number, so I told you कि जो standard form हमारे पास complex number की होती है, that is what? That is a plus iota b. Okay, and here a represents the real number and b also represents the real number. But this iota that I am talking about here, this iota is what? It is the imaginary number. Okay, so any number of the form a plus iota b. Okay, any number of the form a plus iota b where a and b both are real numbers, that is defined as what? That is defined as a complex number. Okay, कोई भी number जो हमारा a plus iota b form का है, that will be considered to be a complex number, provided that we have a and b which are the real numbers. Okay, so as you can see, अगर मैं देखूं तो यहाँ पर ये जो मेरा a है, this forms the real part. Okay, and यहाँ पर जो ये मेरा b है, this forms the imaginary part. Okay, this a, when I'm saying complex number z is equals to a plus iota b, so this a forms what? This a forms my real part, and this b forms what? This b forms my imaginary part. Okay, cool. So we write it as in this way: real part of z and imaginary part of z. So when I'm saying real part of z, I mean to say I'm talking about the real part of my complex number z, and when I'm saying imaginary part of z, so I'm talking about the imaginary part of my complex number z. Does that make sense to you or not, guys? Everyone, are you clear with this, guys? Come on, tell me. Are you there, guys? Please tell me, are we clear till here or not, so that we can accordingly continue, or we can accordingly talk again about any particular topic that you couldn't understand out of here. Hanji, anything you have to say till now, guys? Okay, sorry, let's move forward. So here we have the number that we are talking about, a plus iota b, where a and b are real numbers. It is defined to be a complex number. Then we have 2 plus iota 3. We talked about the examples of complex number. Then we have, for the complex number z equals to a plus iota b. A is the real part, as I told you, that is denoted by a real part of z, and b is called the imaginary part. B is called what? B is called the imaginary part, that is denoted by imaginary part of z of the complex number z. Okay, so for example, if z is what? For example, if z is 2 plus 5 iota, then real part of z will be 2 and imaginary part of z will be 5. Is that clear to you or not? Okay, so if we have z equals to 2 plus 5 iota, then real part of z will be 2 and imaginary part of z will be 5. Clear? Now see, we talked about real numbers. We have been talking about real numbers since very beginning. Okay, since the time when we started talking about numbers. So the point here is that we always have an algebra to follow. So when we talked about numbers, we talked about linear algebra that we follow for all our real numbers or natural numbers or whole numbers. Now when we are talking about complex number, so we will study the algebra for complex numbers, okay? Like how to add two complex numbers, how to put two complex numbers equal to each other, what does it mean, how to subtract two complex numbers, and how to multiply two complex numbers, or how to divide complex numbers. We're going to talk about these particular things. Okay, so two complex numbers, when I'm talking about them, two complex numbers, z1 equals to a plus iota b and z2 equals to c plus iota d are equal. We can say that these complex numbers are equal only and only when we can say that these two given complex numbers are equal when a is equal to c and b is equal to d. Are we getting this, guys? So we can say that the two given complex numbers are equal when a is equals to c and b is equal to d. Is that clear to you? यानी कि कहने का मतलब ये है कि जब मैं बोल रहा हूँ कि दो कॉम्प्लेक्स नंबर इक्वल हैं, okay, when I'm saying that two complex numbers are equal, okay, when I'm saying that two complex numbers are equal, it means that their real part should be equal, okay, their real part should be equal and their imaginary part should also be equal. Okay, so if I have z1 as a plus iota b, so my real part here is a and my imaginary part here is b. When I'm talking about z2 equals to c plus iota d, my real part here is c and my imaginary part here is d. And when I'm saying that these two complex numbers are equal, I mean to say that a should be equals to c, which means real part of z1 should be equal to real part of z2, and imaginary part of z1, that is b, should be equal to imaginary part of z2, that is d. Does that make sense to you guys or not? Okay, so two complex numbers, z1 equals to a plus iota b and z2 equals to c plus iota d, will be equal if a is equal to c and b is equal to d. Are we clear with this, guys? Come on, tell me. Why are you not replying, guys? Please let me know. I mean, are we clear till here or not? So that was some basic things about complex numbers, and you know, to be very frank, that's not possible for us to complete everything about complex number, to complete each and everything, because we have so many things when we talk about complex numbers. We have iota to start with that we are discussing right now, then we have algebra for complex numbers when we will discuss how to add two complex numbers, how to divide two complex numbers, how to find their multiplicative inverse, how to subtract them, how to multiply them. Moving forward, we will talk about what is the conjugate of complex number, what is the modulus of complex number, what are their properties. We're going to solve so many different questions based on these particular things. And then moving forward, we'll talk about argument, which we also call amplitude of a complex number, like how do we represent a complex number on a Cartesian plane. Then we have polar form of a complex number. We'll talk about the trigonometric approach, the vectorial representation of complex number. Then we have so many questions based on that. So there is a lot to cover when we talk about complex number, and it's practically not possible to talk about everything in just one session of 1 hour. Okay, so that is why what we do, we have courses published on Unacademy. We have a proper course on complex numbers on Unacademy. So we take live classes over there. Okay, that's a live platform, just like we are connected over here on a live platform. So similarly, we'll be connected on Unacademy Plus on a live platform where we'll be having so many students to join us, and I'll be teaching over there the complex number, and we have divided this particular topic into multiple sessions over there so that we can cover it completely with enough number of questions, okay, with all the concepts covered, right? So that is something that is very important, and that's why I always recommend students to have an Academy Plus subscription so that we can have a proper discussion about any topic over there. Okay, so we're gonna have doubt clearing sessions over there. The separate doubt clearing sessions will be there. when you can simply ask your doubts, you can practice as much as you want to, and then we have a session completely dedicated to doubt clearing. You can come up with your questions, you can post your questions, we can have a discussion on all your questions whatever you have. Similarly, we have quizzes as well. So it's very important to be aware about ourselves, like where we stand, okay, how much we have done, how much is left. So we have the quizzes as well, where we have questions based on particular topic. Okay, we ask those questions, and you have enough time to solve them. So just to be on the same page, like when we are teaching and you are learning, so whether you are getting things right or not. If yes, that's great. If not, then we can surely go ahead and work on those areas where we have some problems. So that's how we have a customized and a proper managed system of moving forward on an Academy Plus. So you can always have a subscription on an Academy Plus. For the first month, you just need to pay 99 rupees if you use my code, that is Suyash10, that I'm going to mention over here in the chat, so that you can just note it down if you want to. So that is my code. Yeah, so I've just mentioned it over here. That's my code, that is Suyash10. You can use this code and you can avail the first month at just rupees 99 by using this code on an Academy Plus in your category, that is class 11th. And you can find multiple educators teaching multiple subjects, out of them me teaching mathematics to you. Okay, so that's how it works, and that was just a glimpse of an Academy Plus that can actually benefit you a lot. So now let's come back to our topic that we have to discuss here, and that is complex number, and we have some questions over here, so let's begin with them. So as you can see, we have a question where we are saying that 4x plus iota 3x minus y, 4x plus iota 3x minus y is equal to 3 plus iota times minus 6. Okay, I repeat what I just said. 4x plus iota 3x minus y equal to 3 plus iota times minus 6, or minus 6 times iota. Okay, here x and y are what? X and y are real numbers, and I am supposed to find out the values of x and y. Okay, so that's a question that we have. 4x plus iota times 3x minus y equal to 3 minus 6 iota, and here x and y are my real numbers, and I'm supposed to find out the value for x and y. So now guys, let's understand this, how we're going to do this, how we are going to move forward with this. So we have this question. Okay, now again, as I told you in the last slide, that when I'm saying that my two complex numbers are equal, when I'm saying that z1 that have been given to me, let me just have the pen for you. Yeah, so when I'm saying that z1 is equal to z2, what does it mean? It means that the real part, okay, which is a over here, is equal to the real part of z2, that is c over here, and the imaginary part of z1, that is b over here, is equal to the imaginary part of z2, that is d over here. Okay, so that's how we compare things, and then we'll be having a equal to c and b equal to d. Okay, cool. So we have a question here when we are saying 4x plus iota times 3x minus y equal to 3 plus iota times minus 6. Okay, now again, when I'm saying that these two complex numbers are equal, when I'm saying what? When I'm saying that these two complex numbers are equal, what does it mean? It means that their real part will be equal, which means 4x will be equal to 3. Does that make sense to you guys? And similarly, 3x minus y, that is the imaginary part, will be equal to minus 6. That is again my imaginary part. Okay, and that is what I have written over here. 4x equal to 3, that is here with me, and 3x minus y equals to minus 6, that is again here over with me. Are we clear with this, guys? Everyone, are you getting this, how we are doing these things? Guys, come on, tell me. Okay, so we have 4x equal to 3 and 3x minus y equal to minus 6. So from here I can say that x would be equal to what? X would be equal to 3 by 4. That's what I can say, right? X would be equal to what? X would be equal to 3 by 4. And when I put this x, when I put this value of x over here in this equation, I will find out my value of y. That would be what? That would give me y equal to 33 by 4. Okay, So I have x equal to 3 by 4 and I have y equal to 33 by 4. Are we clear with this, guys? Everyone, please tell me, guys. Okay, so we can take it in this way as well, that we have two variables here, one being x and one being y. I need to find out the value of x and y, and to find out the value of two variables, I need to have two equations with me. Okay, and here the two equations that I'm talking about is the first, when I'm going to put real part equal to real part, okay, and the second when I'm going to put imaginary part equal to imaginary part. Okay, and when I do that, I get these two equations over here, and with these two equations I can find out the value of x and the value of y. Okay, so that's how we can solve any equation that is given to us for what, that is given to us for finding out our real part and imaginary part, or for finding out x and y whenever two complex numbers are given equal to us. Okay, now then we have the algebra of complex numbers to move forward with. So as you can see, we are going to talk about how we can add two complex numbers, but I'll come to this later. Before that, I want to discuss something else with you, that is the power of iota. Okay, so we're going to talk about this now. When I'm saying power of iota, what do I mean by this? When I'm saying power of iota, what do I mean by this? So as I told you, iota is what? As I told you that iota is root of -1. We discussed that. Iota is what? Iota is root of -1. And when I'm saying iota square, so iota square is what? So when I'm saying iota square is equal to root of -1 ka whole square, that is -1. Okay. Now if we talk about iota cube, now we know iota square is what? Iota square is -1, so we have -1 into iota. Getting this, guys? Come on, tell me. We have iota cube, all or not? Guys, come on, tell me, are we clear with this? Okay, sorted. Let's move forward. This is iota to the power 3. If I need to find out iota to the power 4, so that will be iota square ka whole square. Now iota square, iota to the power 2 is what? Iota to the power 2 is -1. So basically we have -1 square, isn't it? We have what? We have -1 square, and -1 square can be written as 1. So here we have something to deduce, and that is I to the power 4 is going to be 1. And when I'm saying that I to the power 4 is going to be 1, what about I to the power 8? I to the power 8 is nothing but I to the power 4 ka whole square. And when I to the power 4 is 1, that means I to the power 4 ka whole square will be 1. Okay, let's talk about I to the power 12. So when I have I to the power 12, I can write it as I to the power 4 ka whole cube. Okay, when I to the power 4 is 1, so 1 ka whole cube will be 1. Similarly, if I have I to the power 16, so I can say I to the power 4 to the whole power 4. Okay, which means I have I to the power 4 as 1, and 1 to the power 4 is 1. Okay, so basically the point that we need to note here is what? The point that we need to note here is that whenever I'm talking about the powers of iota, whenever I'm talking about the powers of iota, I need to make this point very clear in my head, that I just need to divide it by 4. Whatever power is given to me, let's say I've been given I to the power 500, or I to the power 691, or I to the power 231, or I to the power 27, or I to the power 358, anything like that. So I just need to divide it by 4. I just need to divide it by 4. I just need to find out the remainder. So जितना भी वो 4 से completely जाएगा, guys listen to me, जितना भी वो 4 से completely जाएगा, उतने part की value 1 हो जाएगी, because we know I to the power 4 is 1, I to the power 8 is 1, I to the power 12, जितने भी 4 के multiples हैं वो अगर I की power में आएंगे तो उन सब की value कितनी होगी? उन सब की value 1 होगी. Are you getting this, guys? All of you there, are you getting this, guys? Please tell me quickly. Guys, that's very important to let me know if you are clear with these things or not, so that we can accordingly move forward. Please tell me, guys. I am still not getting any response from your side, but that's okay. Let's move forward with this. Yeah, so as I was telling you that I to the power 4 का मेरे पास कोई भी मल्टीपल होगा, और आई शुड से कि I की पावर में अगर मेरे पास 4 का कोई भी मल्टीपल है, okay, let's say I have I to the power 8, let's say I have I to the power 12, or let's say I have I to the power 16, or let's say I have I to the power 20. So in all these cases what we'll have, in all these cases we'll have उस I to the power की वैल्यू 1. So what we do is we find out कि जो भी हमें I की पावर दे रखी है, ओके, वो हम लोग किस फॉर्म में ब्रेक कर सकते हैं, एंड उसको अल्टीमेटली हम इनमें से किसी एक फॉर्म में ब्रेक करेंगे. तो या तो वो I to the power 4 के प्लस 1 के फॉर्म में आएगी, या फिर वो I to the power 4 के प्लस 2 के फॉर्म में आएगी, या फिर वो I to the power 4 के प्लस 3 के फॉर्म में आएगी. Okay, and if we have it in the form of I to the power 4k, it is going to be 1, as I told you. जितने भी multiples हैं 4k उन सब की वैल्यू 1 होने वाली है. If that is 4k plus 1, for example I have I to the power 25. Okay, so if I have I to the power 25, तो इसको कैसे सॉल्व करूंगा मैं? अगर मेरे पास I to the power 25 है तो इसको मैं कैसे सॉल्व करूंगा? So this is nothing but 6 times 4 is 24, and then plus 1. तो यहाँ पे आपकी ये फॉर्म आ गई I to the power 4k plus 1 की, that is 6 times 4 plus 1. Okay, so I to the power 24 will be 1, and I'm left with I to the power 1, so it will be I to the power 1. The value will be equal to I to the power 1. Okay, similarly when we have I to the power 4k plus 2, so this will be equal to I to the power 2. इसकी जो वैल्यू होगी वो I to the power 2 यानी कि I square के इक्वल होगी, that is nothing but minus 1. Okay, similarly when we have I to the power 4k plus 3, when we have I to the power 4k plus 3, तो इसकी वैल्यू किसके इक्वल होगी? I to the power 3 के, and I to the power 3 is nothing but minus 1. Guys, are we clear with this? ये सब समझ में आ रहा है या नहीं? We talked about it here, right? I to the power 3 is what? Minus 1. I to the power 4 is what? 1. I to the power 2 we already know, that is minus 1, that is why we have written it here. I to the power 5 is what? Again, this is 4 times 1 plus 1, so it is I, as you can see over here. Okay, and this is I to the power 6, that is 4 times 1 plus 2, so this is minus 1. Why? As it is written over here. Okay, so that's how we do it. Are we getting this, guys? Everyone? Guys, are we getting this or not? Please tell me. Is that clear to you all? Okay, so let's move forward accordingly. So we have some questions to solve on these bases that we have just gone through till now. So if we have I to the power 35, okay, so let's talk about this question first. If we have I to the power 135, so how I'm going to solve it? Again, I'm going to divide it by 4. I'm going to divide 135 by 4, and I have the remainder as what? I have the remainder as 3. Okay, so when I divide 135 by 4, I have the remainder as 3, which means what? Which means that I can write it in this way: I to the power 135 is equal to I to the power 3, and this I to the power 3 can be written as minus 1. Is that clear to you guys? Everyone? I to the power 135 can be written as I to the power 3, and this I to the power 3 can be written as minus I. So wherever I'm calling it minus I or I, it's nothing but iota that I'm talking about. Okay, so I am actually saying iota. When I'm talking about I, it's basically iota that I'm talking about. Okay guys, cool. Okay, so I to the power 135 is what? I to the power 135 is minus of iota. Is that clear to you? Sorted. So let's move forward. Now then we have I to the power 19. The next is I to the power 19. So how we are going to solve I to the power 19? So when I have I to the power 19 with us, we can break it in this way. Again, this 19 can be written as what? This 19 can be written as 4 times 4, that is 16, and then we have plus how much? Plus 3. Okay, that's how we can write it, right? We have 4 times 4, that is 16, and then we have plus 3. That's what I have I to the power 19. Okay, and this I to the power 19 can be written as I to the power 3. Why? Because again अगर आप देखो तो आपका 16 जो है वो 4 times 4 है, which means 4 का multiple है. So I can write this 19 as 4 times 4 plus 3. I to the power 4 becomes 1. So I'm left with I to the power 3, and I to the power 3 is nothing but minus iota. So from here, what do we deduce? What do we understand? What do we get as a finalization formula? So basically, whenever you are talking about I to the power anything, anything means anything. Okay, whenever you are talking about I to the power anything, it is going to be what? Whenever you are talking about I to the power anything, it is going to be either I to the power 1 or I to the power 2 or I to the power 3, that's it, or I to the power 4. Okay, how? Because you are always going to divide it by 4, and you are always going to see that what you are getting. Either you are getting 4k or 4k plus 1 or 4k plus 2 or 4k plus 3. So that is your objective every time, each and every time. This is what you need to think of. Getting it, guys? Everyone? Are we clear with this now? Clear, guys? Sorted? So now on this note, let's move forward. Let's have some more questions, and then we will be moving forward with the properties, the algebra of our complex numbers. So we have I to the power minus 999. That's the next expression, or I should say what we have. I to the power what? I to the power minus 999. That's what I have here. Okay, so when I talk about I to the power minus 999, again what I'm going to do? When I have I to the power minus 999, again what I'm going to do? Again I'm going to divide it with what? Again I'm going to divide this 999 by 4. Okay, let's divide it with 4. When I divide this 999 by 4, I have what? I have I to the power 3 left. So first of all, what I've done, as you can see, first of all I've got this minus removed. How? I got it in this form, I to the power minus 999. I wrote it in this form, 1 upon I to the power 999. Okay, I wrote it in this form, 1 upon I to the power 999, and now I have 1 upon what? I to the power 999 divided by 4. So 996 will be completely divisible by 4, and I will be left with 3 as denominator. Okay, so I can write as remainder, so I can write it as I to the power 3. Getting it, guys? Everyone, I can write it as what? I can write it as I to the power 3. This is what I'm left with, I to the power 3. Okay, cool. Everyone clear? Now when I have this I to the power 3 with me, so again what I'm going to do, either I can keep it as I to the power 3, that will be minus 1. तो पहले या तो मैं I to the power 3 की वैल्यू पुट कर सकता हूँ, that is minus I, या फिर क्योंकि अल्टीमेटली मेरा मोटो क्या है, अल्टीमेटली मेरा मोटो यही रहता है, अगर आप यहाँ पर देखो तो जब भी मेरे पास I जो है वो डिनोमिनेटर में होता है, तो माई मोटो इज ऑलवेज टू मल्टीप्लाई इट विथ समथिंग, जिससे कि मेरा I जो है वो न्यूमरेटर में ही आ जाए और डिनोमिनेटर में मेरे पास सिर्फ एक नंबर रह जाए. ओके, राइट, जैसे यहाँ पर है, तो यहाँ पर भी मेरा मोटो क्या है कि ये नंबर रह जाए और I के टर्म्स मेरे न्यूमरेटर में ही आए. ओके, सिमिलरली यहाँ पर भी अगर आप देखो तो जब ये I मेरा डिनोमिनेटर में है, सो माय मोटो इज कि ये किसी भी तरीके से मैं कहाँ लेकर आऊँ, ये किसी भी तरीके से मैं न्यूमरेटर में लेकर आऊँ. ओके, सिमिलरली here as well, right? So the same pattern we are going to follow for everything, right? So now as you can see here, we have what? As you can see here, we have 1 upon I to the power 3. तो अगर मैं अपने आयोटा का मल्टीप्लाई, या आप बोलिए अगर मैं अपने I का मल्टीप्लाई किस में कर दूं, अगर मैं अपने I का मल्टीप्लाई डिनोमिनेटर में भी कर दूं एंड मैं उसी I का मल्टीप्लाई न्यूमरेटर में भी कर दूंगा, so what will I have? I will simply have iota upon iota to the power 4. Makes sense or not, guys? Isn't it? Because when I'm going to multiply this I to the power 3 with iota, with I, so I'll have to multiply it in it with the denominator and with the numerator as well. Okay, so we have what? So we have iota upon 1, if that is clear to you guys, everyone. Okay, we have iota upon 1, and this can be written as iota. This can be written as what? This can be written as iota. Is this clear to all of you? Please tell me, guys, everyone. Are we clear till now? Okay, now let's take one more question and then we'll be moving back to the algebra of our complex number. And that particular question is this one. As you can see, I have minus of root of minus 1. Okay, I have minus of root of minus 1 to the whole power 4 and plus 3. That's what I have. Okay, what I have minus of root of minus 1. I have minus of root of minus 1 to the whole power 4 and plus 3. Okay, again I'm repeating this, guys. I have minus 1 root of minus 1 to the whole power 4 and plus 3. That's what I have. Okay, now when I'm gonna convert this into this form, what will I do? When I'm gonna convert this into this form, so I will have minus 1 का रूट क्या होता है? -1 का रूट होता है मेरा I और iota. ये जो मेरा टर्म है, this term, okay, when I'm talking about this particular sum, so this will be my iota, this will be my iota, right, guys? Root of -1 will be what? Root of -1 will be my iota. Okay, and I have a minus sign as well in front of it that I'm gonna put here like this. Okay, so now we have minus of iota to the whole power 4 and plus 3. Now understand very carefully what I'm saying. When I'm gonna break it, so this will be minus of I to the whole power 4n into minus of I to the whole power 3. That's what I have now. Getting it, guys? Everyone, please tell me, guys. Come on. So we have what? We have minus iota to the whole power 4n into minus iota ka whole cube. That's what I have. Minus iota to the whole power 4n into minus iota to the power 3. That's what I have here. Okay, sorted? Cool. Now let's move forward. This minus iota to the power 4n can be written as minus iota की power 4 की whole power n. Minus iota की power 4 to the whole power n. Now, when you have minus iota, let's write it in this way. Minus iota into minus iota into minus iota into minus iota. Okay, so I have these 4 minus iota over here, as you can see. Okay, when I'm going to multiply this, can't I write it in this way, minus minus plus, and so I have minus minus plus, plus minus minus, and minus minus plus. So I have plus over here, and with this plus I have iota to the power 4, right? Getting it? So it becomes what? All in all, it becomes iota to the power 4. All in all, it becomes what? All in all, it becomes iota to the power 4. That's what I have here. Okay, all in all, it becomes iota to the power 4. Got it, guys? Sorted? Cool. So that is what I have written over here. This is my plus iota to the power 4, and that would be 1. Similarly, I can do the same for minus iota to the power 3 as well. So minus iota to the power 3 will be minus iota, minus iota, minus iota. So this will be minus 1 into I to the power 3. Okay, this will be minus of I to the power 3. And I to the power 3 is what? I to the power 3, as you can see here, is minus iota. So minus of minus iota will be plus iota. Is that clear to every one of you, guys? Are we clear with this? Guys, are we clear with this or not? Please tell me, come on. Okay, so keeping this in mind, let's move forward and let's talk about something over here, which are the properties, or I should say the algebra of complex numbers. So We are left with just 9 minutes for this particular session, and I'm going to cover as much as I can. But again, guys, I'm going to tell you about Unacademy Plus, that you all can subscribe to Unacademy Plus using the code Suyash10. That is SUYASH10, Suyash10, and you can get the first month subscription at just rupees 99. This is the one thing. Apart from that, what are the benefits over there? So we are going to have a complete course on not just complex number but on all the topics of class 11th mathematics. We're going to talk about them, we're going to discuss them, we're going to have sessions over them. We are going to discuss so many questions along with all the concepts. Apart from that, there will be doubt clearing sessions in place, which will be for all your doubts. You can ask any of your doubt at any point of time. Similarly, we are going to have quizzes as well. So just to be on the same page, whether to confirm that you are getting the things right or not, we are going to have quizzes as well, where you can and we can as well analyze your performance, how you're performing and all that. So that's how we are going to proceed on Unacademy Plus. So all of you are suggested to download Unacademy Learning app and subscribe to Unacademy Plus, and so that we can meet over there to have the multiple sessions on complex numbers. Okay, so we have the algebra of complex numbers over here as you can see. So when I talk about addition of two complex numbers, what do I mean by that, and how am I going to do that? So when I'm talking about addition of two complex numbers, so let's say I have the first complex number as z1 equals to a plus iota b. Okay, this is the first complex number that I have. When I'm talking about the second complex number, that is z2 is equal to c plus iota d. Okay, so the first complex number z1 is a plus iota b, and the second complex number z2 is c plus iota d. Okay, when I will be defining their sum, when I am going to define their sum, so the sum will be z1 plus z2. Okay, the sum will be what? The sum will be z1 plus z2. And how to add these two complex numbers? So keep this in your mind every time, that when you are adding two complex numbers, when you are adding what? When you are adding two complex numbers, so you are going to add what? You are going to add real part with the real part. You will be adding real part of complex number with the real part of complex number, and you will be adding complex imaginary part of real number with the imaginary part of other real number. Okay, so it will be like this. When you have a plus iota b plus c plus iota d, so it will be like a plus c, that means you are adding the real parts. A plus c, that means what? A plus c, that means you are adding the real parts, plus iota times b plus d, which means you are now adding the imaginary parts of these two complex numbers. Makes sense or not, guys? Come on, tell me quickly, guys. Sorted? So it's going to be z1 equals to a plus iota b and z2 equals to c plus iota d. These are two complex number. Z1 plus z2 when I'm going to do, so that will be a plus c and plus I times or iota times b plus d. Okay, so that will be, you are adding real with the real and you are adding imaginary with the imaginary. So if we take an example on this, so we have 2 plus 3 iota or 2 plus iota 3 plus minus 6 plus iota 5. When I'm going to add them, so I'll have 2 minus 6, that is nothing but what? Minus 4 I have here. Okay, and then we have 3 plus 5, that will be here 3 plus 5, so I have 8 iota here. Okay, so it becomes what? It becomes minus 4 plus 8 iota. Are we getting this, guys? It becomes minus 4 plus 8 iota. Is that clear to you all or not? Okay, so this is how we define this. 2 minus 6 is minus 4 and plus iota times 3 plus 5, that is minus 4 plus 8 iota. Okay, are we clear with this, guys? Come on, tell me, everyone. That's how we add two complex numbers. Now if I talk about their properties, so just like we have closure law in algebra, we have it here as well. As you can see, z1 plus z2 if is also a complex number. जैसे z1 complex है वैसे ही z2 complex है, and वैसे ही z1 plus z2 भी complex होगा. If I have z1 plus z2, so I can do either z1 plus z2 or I can do z2 plus z1. I'll be getting the same complex number. Then the associative law, which states that for three complex numbers z1, z2, z3, we have z1 plus z2 plus z3 equals to z1 plus z2 plus z3. Okay, then we have the existence of additive identity, which states that there exists the complex number 0 plus iota 0. तो बेसिकली एक ऐसा कॉम्प्लेक्स नंबर जिसको कि अगर मैं अपने गिवन कॉम्प्लेक्स नंबर में ऐड करूं, सो आई शुड गेट द सेम कॉम्प्लेक्स नंबर एंड दैट इज नथिंग बट 0. So this is known as what? This is known as additive identity. This 0 is known as additive identity. Okay, sorted. Then we have the existence of additive inverse. What is additive inverse? So that is something that when I add this complex number to the given complex number, I should get 0. Okay, when I add this complex number to the given complex number, I should get what? I should get a big 0. So what does it mean? It means कि अगर मेरे पास एक complex number है that is a plus iota b. If I have a complex number what? If I have a complex number that is nothing but a plus iota b, and if I'm gonna add the negative of that complex number, that is minus a plus iota times minus b, so this will give me what? This will give me 0. So this is known as additive inverse of a given complex number. So if I have a complex number z, then its additive inverse will be minus of z. Okay, then we have the difference of two complex number. Again, very simple, as you can see, z1 minus z2 will be z1 minus z2. So again, you're gonna subtract real part with the real part, and you're gonna subtract imaginary part with the imaginary part. That's how you're gonna do this. Okay, so you have 2 minus iota minus 6 plus 3 iota, that will be 2 minus 6. Okay, and then you have minus 1 minus of minus 4 iota. Okay, and that's how you can solve this particular thing. Or I should say, okay, so we already have the minus over, I mean, you can do minus 1 minus 3. Okay, got it. Then we have the multiplication. So to discuss multiplication we need some time, and that is not possible over here, because when we multiply it in this way. जैसे कि हम लोग a plus b into c plus d करते हैं, बिल्कुल वैसे ही हम लोग यहाँ पर करते हैं. तो this into this plus this into this, and then we have plus this into this plus this into this. That's how we multiply two complex numbers. Okay guys, so that was the story that we had to discuss in this particular session. That was the story that we talked about in this particular session regarding your complex numbers. I am still not getting the responses from your side, but I hope that you guys understood all this whatever we discussed over here. If you have any questions, if you have any query, I welcome you all on Unacademy platform. We have so many free videos over there as well, so you can always download it, go through my sessions on multiple topics on 11th and 12th mathematics, and then you can ask me whatever question you have. You can go ahead and ask all your questions in the comment section, or you can either message me over there. Okay, and similarly, you can, if you feel like, you can take the Unacademy Plus subscription as well using my code Suyash10 at just 99 rupees for the first month, so that you can explore the things over there. You can explore how managed we are having the courses over there, how effectively we take quizzes, and we have the doubt clearing sessions as well. So that was all about, guys, from my side on complex number. I hope you understood it in the right way, and thank you so much for connecting with me. Thank you so much for being there, and I hope to see you soon again in the coming month, that is May. Till then, goodbye guys, take care and be with your family. These are the strange times going on. Okay, thank you so much guys. Hope you had a great time.